Welcome back to another Daishinfinity video. In this video, we're going to talk about the derivative chain rule formula, which states that f of g of x, which is just a composition of f of g of x prime is the same thing as f prime of g of x times g prime of x. Now, I'm going to prove this formula by using the limit definition, so let's dive right in. Before we start doing all of this, we have to take in consideration that f prime of x as a limit definition is the limit as h approaches 0 of f of x plus h minus f of x over h. And now since we have f of g of x O prime, we have to take in consideration that we have to put the x plus h into the g of x and not into the f of, you know what I mean. So f of g of x prime is the same thing as the limit as h approaches 0 of f of g of x plus h minus f of g of x and all over h. Now the question is, how can we continue? The right answer to continue is to look at the g of x plus h minus g of x. Now look at this pattern. We have the g of x plus h and the g of x, and then the h. Now we know that the limit of g of x plus h minus g of x over h, where h approaches 0, is just the same thing as g prime of x. So we have to multiply something by something such that we can take the similarity of this expression and somehow factor it out and then get some g prime of x in. So the thing we can do is we can take g, so we can multiply with another fraction g of x plus h minus g of x and divide the whole thing by its same expression. When I do this, when g of x plus h minus g of x is not equal to 0, stating that g of x plus h is never equal to g of x, well, it will be equal to g of x when h is 0. So h is not equal to 0. And this is valid because the limit definition says that h is approaching 0, so h will never get to 0. That's why you can multiply this by its fraction, and every fraction where the denominator and the numerator are both the same, it's just equal to 1. So when you multiply by the this fraction, it will just be multiplied by 1, and everything by 1 is equal to the thing by itself, so we'll just have the same thing. Now what we're going to do is we're going to write it again so that you'll understand what I mean. So what we know about the limit definition is that the limit of a function, the derivative of a function is a limit as h approaches 0. In another way, written as f of x plus h minus f of x all over x plus h minus x. Now if we divide x plus if we take the difference between x plus h and x, it will just be equal to h. But we can write it this way because the pattern follows like this. We have the x plus h and the x, and the x plus h and the x. Now the x plus h and the x are both the inputs of a function f of x, so we have to take a look at the inside, and the inside is just over here. We have g of x plus h and g of x. So if we take the g of x plus h and the g of x down here, then we'll just have the limit definition. That's what we're going to do. And where do we find it? We just find it over here, g of x plus h and g of x. So I'm just going to put this over here and the h just over here, such that we'll have an expression like this. So we will have the limit as h approaches 0 of f of g of x plus h minus f of g of x all over g of x plus h minus g of x times, now we take the fraction g of x plus h minus g of x, or the whole thing over h. Now we have multiplied those two quantities, so we'll take the limit of those individual quantities. So the limit of a times b, Okay, I'm just going to write it down. The limit of any x going to any number a of, let's say, f times g is just the limit of x approaching a of f times the limit where x approaches a of g. So we'll just take the limit of these two things individually, and we'll get the limit as h approaches 0 of f of g of x plus h minus f of g of x, all divided by g of x plus h minus g of x, times the limit as h approaches 0 of g of x plus h minus g of x, all over h. Now what do we have? We have the definition of the derivative over here, which is just g prime of x, and we multiply it by the limit definition of f of g of x. The reason why I'm just saying is the f of g of x prime is because when we take the limit definition of a normal derivative of a function, and when we look at the top right hand side, the thing that is on the top right hand side is the thing by itself, and then we take the prime of it. So if we take the prime of this function f of g of x, then we will just get the limit definition over here. So f prime of g of x times g prime of x is the same thing as the limit of f of g of x. And now we have proven the formula. I hope you like this video, and please like and subscribe and follow for more videos, and we'll see us in the next Daishinfinity video. See ya.